Academy Sessions is our format. We do interviews and lectures and animations, educational stuff around blockchain, specifically for for developers. So we're trying to keep it a bit more technical. Today I'm here with Thomas Bertani, the founder of Oraclize. If you've taken our course already, you know Oraclize because we talk about it. And we invited Thomas because we would like to talk a bit about oracles and data on the blockchain in general. Hey, Thomas, thanks for joining us.
Hi, Elias. Thank you. Thank you for having me here.
Cool. So I would like to start with who are you and what's Oraclize?
Okay, so myself, I'm Thomas Bertani, as you said. I'm involved in this space since 2012. And since then, I've started 3 companies. Oraclize is what is keeping me busy full-time today. What Oraclize is essentially a way to provide data to blockchain applications. So we are blockchain agnostic, and we try to be as flexible as possible so that providing data to blockchain applications is as easy as in any other context.
Cool. So to start out, I'm curious, and I ask this to everyone. How did you get into blockchain? How did you first hear about it, and how did you make your way into the position that you're in now?
Well, this is a good question. As I said, I'm involved in this space since 2012, and it was, I think, August of that year when some friends of mine just briefly were mentioning, that this could be a topic of my interest. So I have a technical background, and at the time I was working on parallel computing on GPUs. So this is something, which in the Bitcoin space was very important back in the days for Bitcoin mining.
Yeah.
Specifically for scientific applications. So it didn't have anything to do with Bitcoin itself. So it's interesting for me to know that there were that many people doing actually GPU mining at the time already, because I already had in my room all these GPUs, but I was using them for something completely different. So I started studying Bitcoin for this very reason, and then it totally blew my mind. I mean, it was so interesting, and so I just decided to move full time to dive into Bitcoin and to move full time to this new industry just after 2 months, I think.
So we've got a pretty technical audience, mostly developers, and so maybe you can give us a quick idea of what is an oracle in a blockchain setting, and how does Oraclize attempt to solve that problem currently?
Yeah, of course. So there are many different definitions of oracles. So usually I start my presentations by just giving my definition of oracle.
Mm-hmm.
And I just try to stay consistent with this definition. So I'm not necessarily saying that this is a correct definition and the other ones are wrong. It's just important to stay consistent so that when we refer to oracle, we are all talking about the same stuff. So an oracle to me is just the party which provides data to the blockchain. So it's the blockchain-aware party in the system, and it doesn't have anything to do with data source. So to me, the data source is the party providing the data. Not in a blockchain context, but in general. So any party creating or distributing data is a data source. So for the number of views of a given YouTube video, it will be YouTube itself. If you think about financial data, it could be well, of course, it could be a Bitcoin exchange. It can be Wolfram Alpha. It can be Thomson Reuters or whoever you want. So, of course, there are really many data sources out there already, and most of the times they distribute data over web APIs, which have no knowledge of the blockchain. And I think they shouldn't, because the blockchain blockchains. There are many different blockchains, and it doesn't make sense for instance, Wolfram Alpha to keep monitoring the Ethereum community and update the client or choose if they should add fork or not. I mean, it is not what they should do. They just want to focus in the in providing data. And so with these definitions, you see that we have two main different entities which are completely separate. So we have the oracle on one side and the data source on the other. So the data source is always blockchain agnostic.
Mm-hmm.
So it doesn't really know anything about the blockchain. And the oracle, on the contrary, is integrated with the different blockchains and will bridge data between a blockchain application and the data source.
Mm-hmm.
So the oracle by itself is not really, creating any data. You're not going to the oracle to ask for the data. You're just using the oracle as like, a proxy, if you want, to access the data source with an abstraction layer in the middle. Does it make sense?
Yeah, of course. So what I'm curious about, you obviously you have a specific implementation that you're using to create proof. So obviously one of the problems, or one of the propositions of the blockchain technology, of public networks, is that you're reducing the necessity to rely on trust. So you've come up with a technical implementation of how you can reduce that, where there's still an element of trust because you're still bringing external data in, but you're reducing that reliance. Can you work us through, say I have a smart contract and I want to react, or I want to set up a trigger, I want to write a function that does something if a certain condition is, if there is a certain condition in external data. Maybe you can walk us step by step through how that would look like using Oracleize.
Yeah, of course. So first of all, as you said, it's very important for the oracle to be somehow auditable, so that an external party can verify if the data provided by the oracle was tampered with or not while being delivered to the blockchain. And this is important because otherwise, the oracle, which is a centralized party, could easily just break the whole security model of the blockchain. So it doesn't make any sense. And you would just be trusting the oracle. But as you said, the data itself is what we want to be the escrow. So if you think about a smart contract which depends on the temperature in London, you don't want the oracle to be choosing what happens to the smart contract. You just want the temperature in London to be the one triggering one event or the other. So the temperature in London is the data, and in this case, it's the escrow of the contract, right? So instead of having an agent which does choose where the funds should go, it's really just the data. So you want the data to be the escrow, and this is why all the rest should be completely auditable, or what you want from Italy is just to have a trustless scenario. Of course, in given the blockchain limitations, or better, the limitations of any decentralized system in not being able to reach out to the internet or find a consensus on a central piece of piece of data, then you can't really provide data in a completely trustless way. So there is always some kind of trust involved. So what we want to do is to minimize this amount of trust, so that you don't have to open too many trust lines. So specifically, the way Oracleize works is via these authenticity proofs. So we call them authenticity proofs or honesty proofs. And essentially, they are a piece of data that you can use to independently verify that the data we have been sending to the contract has not been tampered with while being carried and while being moved around.
Yes.
So what the authenticity proof wants to prove is that given data is really coming from a certain server at a point in time with no alterations. So it would be trivial. There will be no need for such proof if the data source was giving, just a digital signature. But this is not happening today because, there is not really a standard defining which kind of signature the data source should be providing. And there are really many different kind of data sources. So there are really tons of data out there on the internet. And it's not reasonable to expect most of them or many of them to adapt just to the blockchain and to provide this kind of signature. Because this is not what they want to do. I mean, their scope is different.
So you're using TLS Notary, is that correct?
Well, this is just one of the authenticity proofs that we support. So this is the most widely used one at the moment on the public net. So most of the contracts which today are using Oracleize do request the TLS Notary-based proof. So TLS Notary is not something that we invented. It's a project available at tlsnotary.org, if I'm not wrong.
There is a link in the description as well.
Yeah. And it's really interesting project. It wasn't really invented for this use case. It was invented for something completely different, which is decentralized Bitcoin exchange, just to prove, that you really wire transfer.
Yeah.
Something like that. So it's something completely different. But here we want to use it just to verify the authenticity of some data, and that it's really coming from a given data source.
Yeah.
So for the way TLS Notary works, you cannot generate such proof with TLS Notary only. So what we really use is Page Signer, something built on the top of TLS Notary. So we call our proof, for simplicity reasons, just TLS Notary proof, but it really is a TLS Notary based proof. So it's a Page Signer proof, and this Page Signer is what is enabling this piece of data, this proof, to be generated and moved around. So it's interesting because you can verify it at any point in time with no need for the data source to be even still available.
Yeah.
So the data source can even disappear, and you can still verify that the proof is valid. Still, this is not trustless because for the way it works, I can go into details, of course, but for the way it works, it needs Amazon Web Service not to behave dishonestly. So you need to trust Amazon Web Service. And what the proof really proves is that there was a cooperation between Amazon Web Service and Oracleize. So if you do trust Amazon Web Service, the proofs can prove that Oracleize is behaving honestly as well.
Yeah. Okay, so in a way, rather than being or taking out trust, it's more mitigating trust.
It's moving
and taking
trust.
Out.
Yeah, of course. It's moving the trust from a small startup like Oracleize to a big entity, big company like Amazon.
Yeah.
So the idea is that we call, Amazon doesn't have any knowledge of what we are doing with the system,
no, of course.
right? And they have no knowledge of the context in which each proof is being used. So we call, in this case, Amazon the attestator. So essentially what Oracleize wants to do is to provide this, attestators-based proofs as a service. So we are building in-house many other different type of proofs, authenticity proofs, which are based on different attestators. Okay. So the idea is that you can generate more proofs, so not just the TLS Notary one, but you can generate other proofs at the same time for the same piece of data. Yeah. Which is based on different attestators. So, for example, today what we have is TLS Notary one based on Amazon as an attestator. Then we have the Android proof which is available on the testnet at the moment and is being tested by some of our clients and some people around the globe. And this is using as attestators Google and Qualcomm. Then we have other proofs in the workings which are based on technologies like Intel SGX, which we use as attestator Intel itself. So the idea is that at some point you will be able to generate many proofs for the same piece of data. And if the proofs are valid, are all valid, but the data has been tampered with, it will mean that you have Amazon, Google, Intel, and Qualcomm providing wrong data at the exact same time and in the exact way, which is not trustless, but
it's unlikely.
Yeah, it's very unlikely, and our assumption is that it's much safer to expect many attestators, which are even complete companies, not to cooperate in a bad way, other than having the majority of small distributed network of private anonymous oracles claiming something. Because it always depends on how much you have at stake, of course. And in this case, those companies have their reputation at stake.
Yeah. So one of the things that I always wondered about is, for this to work, is so I can get the proof. I can send a transaction to the net. Oraclize picks it up, calls my callback function with the data, and then I can also get the proof. I can check the proof. What do I do if the proof is comes up as invalid? And doesn't this wouldn't this mean that we need a whole ecosystem of Oraclize-like companies, so I can go, oh well, this one doesn't work, or this one the proof is invalid, so I need to use another one. I need to do a fallback.
Well, of course, there are many different options. The idea is that as soon as one proof is invalid, then you can prove that something went wrong. And the idea is that those proofs are stored with some kind of persistent layers. So you can verify at any time whatever proofs Oraclize has generated during the last year and a half, even for different clients, so to everybody. And the contract on its side, of course, should be able to understand if a given proof is valid or not. And if it doesn't, it should have some kind of fallback method. So most of the times, what we suggest for now is just to move the contract to an emergency state, which in general is something which is a good idea to have anyway. So expecting things not to break is not really something reasonable at this point.
No, of course.
In general, for the maturity of the ecosystem.
Yes.
So of course, you could have different players providing Oraclize-based proofs. The idea is that all we do is open source, but the generation of these proofs needs some kind of a dedicated infrastructure.
Yes.
And this infrastructure is not really something that you can buy off the shelves or that you can run on your laptop most of the time. So this is why we have a dedicated infrastructure. It's a distributed system to provide availability, blah blah. You can have many other players providing the same, of course, and this could maybe increase the reliability of smart contracts. But yeah, it's really hard to say at this point in time. It never happened so far. It could definitely happen. It depends on how much money we have at stake. So one thing that we are considering to do for the future, as soon as we have cheap and reliable on-chain verifications of proofs, is that we will put some kind of collateral on the blockchain, so that if a proof is not valid, we can lose our own money. And this is because we already verify many times the proofs we send to the blockchain, and we want to have some kind of commitment, which anybody can verify by itself, because we claim we have no interest in providing wrong proofs, but somebody could simply not trust this and simply rely on this external money that can put this collateral.
Yeah. Okay. So you've already mentioned a few things that you guys are working on, but what's the next thing for Oraclize? What direction are you working into? What are you working on?
We are still a small team, so it's 6 people at the moment.
Mm-hmm.
We are most of us are developers. I would say half of the team is constantly working just on researching new kind of proofs. We have some projects in the workings, are all based on Oraclize, and the idea is that for the next 6 months, we will just be focusing on using this new honesty proofs, this new authenticity proofs. We'll get hopefully the on-chain verification working in a way that it's pretty cheap, and that contracts can really do it for all the proofs, for instance. And the idea is that after that we start to explore some new applications. So we have a new one, which we announced at DevCon in Shanghai, and we have some clients which are they are testing it just now, and we call it auditable off-chain computation. And essentially, what it is an extension of the authenticity proof concept. But instead of proving the authenticity of data, we can prove that starting from a given piece of code, which can be written, with any language, then you can prove that there was a trusted, safe execution of chain, and you can prove that the result is really coming from this piece of code.
Yes.
You can prove it to a smart contract. So this is pretty important because it enables many applications to be finally viable on the blockchain. It's not completely trustless, but it gives a strong guarantee that the execution, the result is really coming from there, which is important even for, some, how to say it, just not to disclose all the information and to have some kind of privacy on the blockchain. Because you can have some kind of interaction with the execution of this off-chain code and still prove that there was a correct execution.
And it's also, I would assume, a scalability question. So you can have a dedicated piece of hardware that can execute something that, of course, that you could not execute on the blockchain with gas limits or in a reasonable time, and you can prove that it was executed. Okay, that's interesting.
Yeah, it's not just for gas limits. It's even for language limitation itself. So think about the fact that, for example, Solidity or the EVM itself at the moment doesn't support, floating point arithmetics.
Yes.
So if you want to do this, then of course you simply have to. At the moment, you will need to have some kind of web API to compute this. It's pretty bad because it doesn't really give any guarantee to the smart contract user that the web API will keep executing the same logic on its side.
Of course. Yeah.
So it's just saying that the computation is coming from there. But what we want to prove instead is that a given piece of code was executed.
So I also always ask this because I think it's quite interesting. In your ideal blockchain world, how does that look like? Say 20 years down the line, everything went exactly how you think it should. How does that look like? How does the future look like?
Well, I think that, today, of course, we have a lot of different blockchains or different solutions that are trying to find their way. And there is still the assumption that there can be different blockchains for different use cases. I'm not a strong, supporter of this idea. So I think that there will be maybe 2 or 3 blockchains out there. And I still believe that the Bitcoin approach is something which is very interesting in the fact that we try to have one blockchain with very strong consistency and which can provide a consensus layer. So I think that the consensus layer was really the very reason why the blockchain was invented in the first place.
Mm-hmm.
And having Ethereum smart contracts to run on the top of this will be fantastic. So I expect, so in my ideal world, there will be maybe a couple of blockchain which really huge security guarantees, which can power the Internet of Value. And the Internet of Value needs this consensus layer. So the Internet of Value is just something where, you know, terms and conditions, the terms of services, the huge paperwork that every day we have to sign to run traditional businesses, is something which is not stopping innovation, and which can really power new applications. So I expect many applications to you know, to grow out there in such environment. And for this to happen, we need this Internet of Value, which needs the consensus layer. So I think it's still you know, early days. So we are building the infrastructure. Tool sets are still missing. It's not mature yet. It will still take, I think, at least 5 to 10 years. But I'm quite optimistic on you know, all the work we are doing. I think it will be very useful for this Internet of Value to become something real.
So all of these infrastructure layers, these different things, could obviously have a profound impact on the way people interact, and, you know, the way things work, the way companies interact, the way work is done. Can you see any threats, or do you feel there are any threats or any downsides to this development?
Well, of course, you know, at the first look, you know, an external observer could think that regulation is something which can slow down such innovation. But I don't think this will really happen. I mean, it's sort of happening already, right? But I think that for regulators, it's just very complex because the technology is difficult to understand. But I think that everybody can see the value in the blockchain to some extent. And for instance, if you think about the EU, few years ago, Germany was really pushing for banning cryptocurrencies, you know. While today, Berlin is, you know, one of the, along with London, is one of the European blockchain capitals. And startups and people are not afraid, you know, of working in this space, even given these regulator strong positions of the past years. And today those positions from the regulators have changed a lot. And those have changed mainly because they are starting to see, you know, use cases. They are starting to see the real implications of this technology. And I think this is pretty much the same that happened, you know. I think this has been said again and again. I will say it just one time more. I think this is like the internet. So, you know, during the first years, it was really hard for people to understand if there was any concrete everyday use for the average Joe of the internet. It looked like something, you know, just which was created for illegal purposes or things like that. But today is very different. So I think that even the blockchain will just provide something else which will sit next to the internet and will enable new applications. So it will, what today is, you know, think about ICOs. So of course, you know, it's still the Wild West. So there is no regulation at all, which can end up pretty badly in some cases. So I expect just to find a good balance where ICOs can still be done, but not in, you know, a way that the regulators will make that sort of pointless. But there will be a good balance where we can have both something which is viable and which can offer some kind of protection for the investors, and at the same time which can really enable the final users to easily invest and interact with in a transparent way with these new kind of entities.
So last question is, every month we have people coming out of the course, some are certified, some are not, and they are looking at, okay, so what are the things that I can do with this? What can I do next? what is your advice for people who've just gone through the course, who have a basic understanding or pretty good understanding how to work with these things? What advice would you give them? Where to go, what to do?
Well, I think that most people who start those courses actually have some ideas in their mind, or they just want to have a good starting point for then diving into this topic or another. And I think they shouldn't at this point be afraid of all the complexities, the regulators, and blah blah. But they should just feel free to experiment, at least on the testnet, and they should just implement their own project, because they at this point after the course, I think that they can. I think that the community that we have out there is something really very important, and they should just show to the community what the idea is with some real code, and then collect the feedback, because it's very easy to, with the blockchain, with the internet, with a good starting knowledge base, to just do something great today. And they just shouldn't be afraid of all these limitations, because the entry barrier is really low today. And one of the main features of the blockchain, in my mind, is interoperability, which means that every time somebody creates a new service, there is a huge value for the whole ecosystem. And by design, I mean, you don't just create a new system which lives in its walled garden and is isolated from all the rest. So it's very important for everybody to create new services and grow the value in this ecosystem, because this is the only way we can expect this technology to grow and succeed.
Cool, excellent. Well, thank you very much. Also, thanks for watching. If you want to know more about the things that we talked about, check out the description. And if you want to see more videos like this, subscribe to our channel. Thanks, Thomas.
Thank you for having me here. Thank you.
If you want to learn more about blockchain, check out our online courses at B9lab Academy, and also subscribe to this channel.